Hey everybody, this is Miss Ali, and we are continuing our series of the math ACT videos. I'm going to share my screen with you. This will be the last one on math, and then we're going to let English take over for a few weeks, but hopefully you found these useful and it's reminded you of some things you might have forgotten. So today we're going to work some area problems. So I wanted to kind of first look at this sheet. This came from a boot camp ACT book, and it talks about some of the formulas you need for the test. I added the pictures just so you could kind of see what, some of the pictures would look like, and put some alternate formulas, like instead of S squared, sometimes we think about square as length times width. Area of a rectangle, of course, you probably already know, length times width. Sometimes you'll see that represented as base times height, like the parallelogram. And then, of course, the triangle and the trapezoid are kind of similar, but they actually have that 1/2 component that you have to be careful to remember about. Base times height again for the triangle. And then the trapezoid has two bases, one at the top and bottom, and those would need to be added together as you do the area. I'm going to try to make sure that all the juniors and the seniors who are retaking the ACT get one of these sheets the closer it gets to March. So you'll have this to kind of take home and look over. Okay, so here's a problem we're going to be doing today. This was off your practice ACT from last week. And so the question is asking area, but they're also talking about a little percent. Let's read it out. The vertices of a rectangle, the corners, if you will, are listed at these coordinates. When the rectangle is graphed in the standard plane, what percent of total area of the rectangle lies in quadrant 3? And just to remind you, if they don't give you this, we start up here in the top and we go against the clock, counterclockwise, as we number these coordinates, 1, 2, 3, 4. They already actually gave that to us in the problem. Okay, let's graph these. So -1 would be to the left 1. And then, of course, -2 would be down 2, to the right and down. To the right and up 3. And then, of course, to finish out our rectangle, to the left and up 3. And I know that you didn't get to write on here, but for the real ACT, you'll get to write all over this. But right now, they're still going to do it on paper. So let's connect this to form our figure. And I'm just going to take the top part for right now to show you how to find mathematically the distance, because the top is going to be the same as the bottom. So you might remember from geometry, if you want to find the distance or length of a horizontal segment on the coordinate plane, you simply look at your x values and you can subtract those x values. So this would be 4 minus a -1, that would turn into 4 plus 1. So this distance would be 5. If it's something this small, though, you can also count 1, 2, 3, 4, 5. So this side has a length of 5, which is also going to be the same at the bottom. And then 1, 2, 3, 4, 5. So when you're trying to do the area formula, which is basically length times width, but you often see it for a square. This is actually a square, not a rectangle. You often see it S squared for the square. So we're going to take these two numbers. We don't need all three of them now. Just two numbers multiplied together, 5 times 5, or 5 squared, which is 25. And if they were asking you just for the area of the square, we would be done with the problem. They want you to go ahead and look at some other area, the area right here of this part that's in quadrant 3. I'm going to just shade it out. And we're going to make a fraction of this area, shaded area, over the total area to come up with a percent. So this dimension is 1 and 2 on just a new rectangle, where the area is going to be length times width or base times height. And these are square units, of course. All right, so now I have my two numbers I'm going to need to finish this problem. So the fraction 2 over 25, the shaded part over the whole entire region. All right, there's a couple of things you can do here. Remembering that percent is out of 100, we could take and go, okay, well, it's easy to see that I can get 25 to 100 by multiplication of 4. And whatever I do on the bottom, I'd have to do on the top, times 4 to get 8, making this 8%. Or if you have your calculator, what might be even easier is to take your calculator and just do 2 divided by 25. And that's going to be 0.08. And of course, to get percent, you multiply by 100, which is going to end up moving the decimal 2 places to give us our percent. And so the answer, correct answer to this was F. 8% of the area is in the quadrant 3. Okay, I'm going to scoot this up just a little bit. So I want you guys to pause the video and take a minute and try number 21 and 22. I mean, sorry, 21 and 24. And the reason I gave you 2 problems is because 24 is going to be super quick. And since both of these have to do with area of a rectangle, I thought they would kind of fit well with the problem that I worked out for you, number 4. So if you'll pause the video and take a minute. And on 24, you're probably going to want to just try to plug in numbers instead of trying to come up with a formula. Okay, hopefully your teacher gave you a few minutes to try to work these 2 problems. Let me go ahead and just start with number 21. So they're telling you that a 5x7 photograph was cut into a 4x6. What is the area of the part that was cut off? So basically, you have a picture that would look something like a very easy rectangle problem. So you have a 5x7, and they've cut it out, and I'm just going to cut it out right in the middle here. So they've cut it into a 4x6, and they're wanting to know what was all this part right here that got cut off to turn that bigger photograph into a 4x6. It's really 2 simple area problems, and we're just going to take the area of the bigger figure and subtract the area of the smaller figure to get this shaded part. So remember your area formula, length times width. So 35 for the bigger photograph, length times width, 6 times 4 for the smaller photograph. And then when we take and subtract these 2 numbers, that will give us the area of the cutoff shaded region, which is C11. So yeah, sometimes they're going to ask you some very simple problems where area is concerned. Again, just knowing the formula is important. Okay, number 24. There is a way to do this with the formula. But if you do it with the formula, you're going to have to know about quadratics and how to factor a quadratic. And since nobody has shown any of those ACT videos yet, I'm sure we will. I'm going to work it out probably a quicker, better way. And that's just to go down the list until you find something that fits this problem. A rectangular rug has an area of 80. So that's what we're looking for. Square feet, of course. And they're telling you that the width is 2 feet shorter than the length. And we want to find out, they want to know what the length is, this part right here. So let's just go through and start with F. If the length was 8, that would make this 6, and then just compute the math really quickly in your head. 8 times 6 is 48, and we want an area of 80, that's out. Now just jump down to the very next one, 10, and that would make the width 2 less would be 8. And there it is right there, 10 times 8 gives us our 80. And so G would be the correct answer. So again, it's probably better for this one to just go down and substitute and try those answers to get the answer really quickly. I'll come back to this one after somebody shows a factoring problem and show you how to do this one the other way if you just want to know out of curiosity. Okay, folks, a little area for you. So I will see you guys soon.